This video is going to cover section 3.2, which is going to talk about independent and mutually exclusive events. So, independent events are events that don't affect each other. They have nothing to do with each other, but you can prove that mathematically. So there are three ways to prove that. They use conditional probability. So the first way is if the probability of A given B equals the probability of A, they're independent, because that proves B doesn't affect A. The reverse is true. If the probability of B given A equals B, then they're independent, because A doesn't affect B. The third one is if the probability of A and B equals probability of A times the probability of B. If you can just multiply them together and they're equal, then they're independent. Any of those three is enough. You don't need all three, you only need one. Any of those three will work to prove they're independent. So, if one event does not affect the other, they're independent. You assume they're dependent unless that's true. So, if any of those are equal, it's true. If they're different or not equal, they're dependent. Some examples of independent and dependent events. Picking a card from a deck. So if you have a deck of cards and you pick one out, you have 52 cards in a deck, 52 cards in a deck. 52. Had a moment there. 52 cards in a deck. If you pick a card out and then you put it back in, there's still 52 cards for your next pick. So with replacement, it's independent. If you don't put it back in, now there's only 51 cards. So when you pick again, the probability is different. So that's a dependent event. When you flip a coin, every single time you flip the coin, the probability is still a half. You could flip it 100 times, it doesn't change the probability. So that's independent. When you roll a die, like a Monopoly die, every single time you roll it, the probability is the same. So it's independent. Rolling it doesn't change the dice. So that's why it's independent. It's kind of a little guideline to being different. So if we look at example 1 here, let's see if we can figure out if these are independent. So let event G be taking a math class. Let event H be taking a science class. Then G and H would be that you're taking math and science. So suppose the probability of G is 0.6. So the probability of math is 0.6 or 60%. The probability of H is 0.5. So the probability of science is 0.5. And then the probability of both is 0.3. Are they independent? So we can choose any of the three. So if I did the first one, that would be probability of math given science equals probability of math. So let's calculate that. So with our given, we put both on top. So that'd be 0.3 over the probability of H, because that's the given. So 0.3 divided by 0.5 is 0.6. The probability of G alone is 0.6. Those are the same. Since those are the same, that means it's independent. So according to that first one, it shows those classes are independent. Let's try the next one. Probability of H given G, does that equal the probability of H? So on top, we would put G and H, which is 0.3. On the bottom, we would put just point G. 0.3 divided by 0.6 is 0.5. Probability of H is 0.5. Those are the same, so they're independent. Let's try the last one. Is the probability of G and H the same as the probability of G times the probability of H? Well, they tell us that the probability of G and H is 0.3. So the probability of G is 0.6. The probability of H is 0.5. If I multiply those together, I get 0.3. Are those the same? Yes. So since they're the same, they're independent. I did not have to do all three. I could pick one. It does not matter which one. So in some cases, the purple's easier because of what I know. In some cases, the orange might be easier. You only have to do one. So because both of the answers were the same, that shows that math and science classes in this situation were independent. Why don't you pause the video and try the U-Try? You don't have to do all three, but you can if you want, and decide if the situation it explains is independent. When you're ready, check and see how you did. Okay. In a bag, there are 6 red marbles, 4 green marbles. That's it. So there's 10 marbles total. Let's see. The red marbles are marked 1, 2, 3, 4, 5, 6. The green marbles are marked 1, 2, 3, 4. O is an odd number marble. S, oh, okay, they're all there's the sample set right there. Okay. Are R and O independent? Are R and G independent? Find the probability of G and O. So let's find the probability of R. So the probability of red is 6 out of 10, or 0.6. Probability of green is 4 out of 10, or 0.4. Let's see. The probability of odd, there's 1, 2, 3, 4, 5. There's 5 odds, so that would be 0.5. And then RORG. Okay. And then if we look in there, G and O, R and O, so we're going to need all of those. So probability of R and O, R and odd, there's 1, 2, 3. So R and odd, there's 3 out of 10. And then green and odd, there's 1, 2. 2 out of 10 by counting in that sample space. So I found all those probabilities. Now let's see what we've got going on here. So probability of red given odd. So on top we put red and odd, which was 0.3. On the bottom we just put odd, which was 0.5. 0.3 divided by 0.5 is 0.6. Probability of red was 0.6. Those are the same, so it's independent. We could have gone the other way. We could have said probability of O given R. Well, orange and red, or odd and red, was 0.3. Probability of red was 0.6. 0.3 divided by 0.6 is 0.5. Probability of O is 0.5, so they're still independent. And then if we multiply probability of R times probability of O, that would be 0.6 times 0.5, which is 0.3, and that matches the R and the O, so all 3 of those showed us independent. So that first question is yes, they're independent. Okay, the second question, are R and G independent? So on top, we put R and G, which is 0.2. On the bottom, we put G, which is 0.4. That gives us 0.2 divided by 0.4 gives us 0.5. The probability of R is 0.6. So these ones are not independent. They're dependent. Let's try that with another one. Let's see if we go the other way. G given R. So on top, G and R was 0.2. R on the bottom is 0.6. 0.2 divided by 0.6 is 0.3 repeating. Probability of G is 0.4. Those are not the same, so that also shows it's dependent. So we have two ways right there that show us they're not. And then if we multiply them together, probability of G times probability of R is 0.6 times 0.4, which is 0.24. That does not equal 0.2. So all three of those ways show that no, it's dependent because none of those are the same. So hopefully you can see that it doesn't matter. You don't have to do all three. You can pick one and it'll automatically show you it's the same or different. All right, so that's independent. Now let's look at mutually exclusive. Two events that cannot occur at the same time are mutually exclusive. So this means they don't share any outcomes. So like a number can't be even and odd, right? It means the probability of A and B, of them happening at the same time, is 0. All right, so when you flip a coin, you can't get heads and tails. Those are mutually exclusive. When you roll a die and spin a spinner, if the spinners are colors and the dies are numbers, they'd be mutually exclusive. If the die has numbers and the spinner has numbers and they have the same numbers, then they would not be mutually exclusive. So let's look at this example and see if we can decide if things are independent and mutually exclusive. So event C is taken in English class. Event D is taken in speech class. The probability of C is 0.75. Probability of D is 0.3. Probability of C given D is 0.75. And the probability of C and D is 0.225. So they already give us all the probabilities. We just need to decide if the answers to these questions. So are C and D independent? So we're going to compare probability of C given D to the probability of C. So C given D is 0.75. They tell us that right here. Probability of C is 0.75. Those are the same, so it's independent. Yes. Mutually exclusive. So probability of C and D is 0.225. Is that 0? No. So they are not mutually exclusive because that's the definition we got right up here. And then what is the probability of D given C? So on top, we put the probability of both. That's the 0.225. On the bottom, we put the probability of what's given. So C is given, and the probability of C is 0.75. So we do 0.225 divided by 0.75, and we get 0.3. All right, so pause the video, and you do the you try 3, and when you're ready, come check your answers. So given this information, I'll use a different color. Given this information, let's see what we can find. B given D. So on top, we need the B and the D. So B and D is 0.20 over the D, because that's what's given, so that's 0.30. So if I divide that, I get 0.6 repeating, or 0.67. Find the probability of D given B. So on top, we still have the both, D and B. But this time on the bottom, we have B. So 0.40. So 0.2 divided by 0.4 is 0.5. Are B and D independent? So I can use either of these. So if I choose A, we said B given D was 0.6 repeating. I would compare this one to B, which was 0.4. Those are different, so they would be dependent. If I had compared B, I would have compared that to 0.3, which is still different and dependent. And then finally, are B and D mutually exclusive? Well, B and D, we were told is 0.2. That's not 0, so no, they are not mutually exclusive. So that is the end of 3.2. Let me know if you have any questions.